there. Sorry, I was just finishing up a workout before I recorded another lesson, so y'all saved me. Well, let's get a lesson in, why don't we? Thank y'all for saving me from the workout. Okay. So today, while I'm getting my screen share all set up, today we're going to look at properties of the triangle midsegment, and then we'll also do other things with it. So we have the midsegment theorem that we're going to look at. We're going to apply it to real-world situations, and then review a little bit. So let's, without further ado, let's jump on into it and see where it gets us. So what is a triangle midsegment? Well, I'm glad you asked. And if you didn't, well, I'll tell you anyways, because it's something we've got to know. So a midsegment of a triangle is a segment that joins the midpoints of two sides of the triangle. So a midsegment of a triangle is a segment that joins the midpoint of two sides of the triangle. Every triangle has three midsegments, which form the midsegment triangle. So all three midsegments form their own little triangle. So just in case I was like, oh wait, what's a midpoint? Okay, I forgot what midpoint was, which made me totally confused. Remember, a midpoint cuts a side in half. So it cuts the sides in half. So each midsegment is a segment that joins two of the midpoints together. That's why we have three, which make their own little triangle. So if we look at this picture here, you'll see that XY, YZ, and ZX are midsegments in triangle PQR. Now, the midsegment triangle of PQR is this triangle formed by the midsegments. So triangle X, Y, Z. That's our midsegment triangle. So now that we know what midsegments are, let's look at the triangle midsegment theorem. So a midsegment of a triangle is parallel to the side of the to a side of the triangle, and its length is half the length of that side. So if we look in this picture here, DE, which is our midsegment, is parallel to AC. That means that DE is 1/2 of AC, Or we could also say that AC is 2 times DE. Okay, so yeah, sure, that makes a whole bunch of sense, but let's actually see it in action, because until we can see it in action, it's just going to be a bunch of gobbledygook. And who likes gobbledygook? Not me. Okay, so in this triangle, we have to show that midsegment KL is parallel to GJ, and that KL is 1/2 of GJ. We have to prove basically what this theorem says. So let's just focus on one line at a time. We're going to get the slope and the distance of one line, and then do the same for the other. So let's first look at KL. So for KL, our slope, well, if we make our triangle here, what do? We rise how many? 1, 2, so we rise 2 and go over 1, 2, 3, 4. Rise 2 over 4, which reduces to 1/2. But this isn't all in vain, because look, we already said 2 and 4. What could I use to find the distance of KL that uses this triangle we just made? This right triangle. The Pythagorean theorem. I could say that 2 squared plus 4 squared is equal to C squared. 2 squared plus 4 squared together gives you 20. Take the square root. So that means KL is approximately equal to 4.47. Okay, so that's our info about KL. For KL, we know the slope, is 1/2. The distance is 4.47. That's what we know about KL. Now, let's see, what can I figure out about GJ? Well, let's see if I can get the slope. So what do I rise on GJ? 1, 2, 3, 4. What do I go over? 1, 2, 3, 4, 5, 6, 7, 8. So I go up 4 over 8, which reduces to 1/2. Using the same 4 and 8, I can find my distance. So 4 squared plus 8 squared equals C squared. 4 squared is 16. 8 squared is 64. 16 plus 64 is 80. If I take the square root, I will get GJ is approximately equal to 8.94. So let's recap. What do we know about GJ? The slope is 1/2. The distance, the length, is 8.94. That's what we know. Okay, so if both of them have the same slope, what's that mean? KL is parallel to GJ. And, well, let's see. What happens if I do 8.94 divided by 2? What do I get? 4.47. Ooh, that means KL is 1/2 of GJ. We proved it. That's all we had to prove. So that wasn't too bad. It seemed like a lot at first, but it really wasn't that bad. Okay, next example. They ask us to find each measure. Well, A asks us about WV. WV, let's see. There's WV right there. What side is it parallel to? RS. So WV has to be half of RS. It's got to be half of the side it's parallel to. So that means WV has to be 8.6 divided by 2. There's no ifs, ands, or buts. It's got to be half of it. So that means WV is 4.3. Okay, the next one they ask about is WT. So WT is this one. What segment do I know of? And I covered the marks up, but there's 3 little lines here. What segment do I know of that has to be congruent to this one? It's the one that's parallel to it. So this is 5.2. This has to be 5.2. So that means WT is 5.2. And then the next one they ask about is WR. Well, here's WR right here. We already found it. We did that when we did the previous one. Well, that's going to make it easy. So what's WR? 5.2. We made that easy on ourselves. Okay, so that's the front. Let's look at the back now. They give us a different picture. Now, one thing I'll say here, we know mid-segments have to be parallel, which means we can use all the deals we learned with parallel lines in Unit 3. Alternate interior, alternate exterior, corresponding, all that good stuff we get to use here. Okay, so let's do it to it. First one they ask about is angle UWT. UWT. So that's going to be this angle right here. Now, you may be looking at that like, how do I know what UWT is? Well, let's think about this for a second. I know that the midsegments here are parallel to my other sides. So if I draw these out, how does that 41 that they give me next to it relate to the one I want? It's going to be a same side interior angle. So if they're same side interior, I just subtract from 180. So 180 minus 41 is 139 degrees. That's the angle they want. So I'm going to erase my little drawings here. As we find things, we can start labeling to make our life easier. So I know this is 139 degrees right here. I know that. Okay. So now it asks about SVU, angle SVU. SVU. That's this angle right here. Well, what can I do to help find it? I know these are parallel. UW and ST have to be parallel because UW is a midsegment. This is probably some kind of transversal. So I'm given a 41 right here. What's my relationship, the angle I want and the 41? What kind are they? Maybe if you turn your head sideways, you can see it a little bit better. These are alternate interior, which means they have to be the same. So this one's got to be 41. So I'm going to erase this part. That's got to be 41 degrees. And then last but not least, they ask about RUW. RUW. So I start at R, I turn at U and go to W. So they're asking me about this angle right there. Well, let's see what I can figure out. Looks like I may have a pair of parallel lines here. And if this line is my transversal, so this line right here is my transversal. I have a 91 up here. What relationship do these angles have? They're corresponding. Since they're corresponding, that means they're equal. So this one has to be 91 degrees. Okay, so there's that example. Example number 3. We want to do a little bit of indirect measurement. So Anna wants to find the distance across the base of the Capulan volcano, which is an extinct volcano in New Mexico. So she's going to measure a triangle at one side of the volcano as shown. What is AE? Well, essentially, she does not want to go into this volcano. So she can make her own little triangle outside the volcano and make sure this is a mid-segment here. Then it'll be all fine and dandy. So notice that BD is a mid-segment. That's a mid-segment. Because B is halfway between C and A, and D is halfway between C and E. So that makes a mid-segment. Now, what do I know about the mid-segment and the side that it's parallel to? To get the side, we just have to multiply this by 2. So BD is 1/2 of AE. Or we could say AE, which is what we want, is 2 times BD. Well, I know BD. So 2 times BD is 775. I can do that real easy. It's going to be 1,550, and we're dealing in meters here. So meters. That's how far it is across the volcano. Okay, next example. They ask us to find N. Well, what's this 25? What kind of segment is this? It's a mid-segment. So how can I get from the mid-segment to the main line? Times it by 2. So 8n plus 10 equals 2 times 25. Which means 8n plus 10 is equal to 50. Subtract our 10. We get 8n equals 40. Divide by 8. Divide by 8. And n is equal to 5. Is that all they ask us to find? Yep. Just find n. So n is 5. Okay, a little review. So A says that AD is the perpendicular bisector of BC. Find the value of Z. Well, AD is the perpendicular bisector. What's that mean about AB and AC? They have to be congruent. So to solve this, I can set these equal to each other. (8z minus 5) equals 5z plus 16. Subtract my 5z. I get 3z minus 5 equals 16. Add 5. Get 3z equals, let's see, 21. I'm out of room, so I'm going to rewrite this up here. I just rewrote it. That's all I did. Divide by 3, and we get z equals 7. Is that all they ask us to find? Indeed it is. So we are done. Okay, so there's that review example done. Now let's look at B. B says in the diagram, are the segments medians, altitudes, angle bisectors, or perpendicular bisectors? Well, let's see what's going on here. So, angle bisect, let's just start here. Angle, the only one that deals with angles is angle bisector. Are we cutting any angles in half? Do we have any proof of that? No. We don't see, unless I draw them, we don't see any little marks in the corner. So we got no proof that that's happening. So they can't be angle bisectors. Altitudes mean they start at the vertex and go straight down the whole triangle. I mean, one starts at G, but then it turns at X. So we can't say it's altitude. Again, median is a straight line from H, for instance, all the way to M. But we turn here at X, not a median. All a perpendicular bisector does is it intersects in the middle on the edge of the triangle at a right angle. That's exactly what all of these do. So therefore, these are perpendicular bisectors. Okay, so that's the notes. I think I'm finally getting cooled down for my workout. So I'm going to go get a drink of water, come back, and we'll do guided practice. So stay tuned.